we will explain a little about what the blockchain technology is, and then a little about the solution that we've come forward with in relation to the GDPR. I don't know if any of you guys know a little about the GDPR already. I know you do.
A little bit.
Yeah? Okay. Yeah, but a little more on that later. So why did we choose to work with blockchain technology? We did that because in our studies at Aarhus University, we've been looking a lot onto project management and architecture and a lot of theory about and models about how we should do stuff. And we wanted to, as we knew that we were going to spend 6 months on this, we wanted to learn something entirely new. And therefore we were talking about maybe looking into chatbots or blockchain. And as you can see here on the Gartner Hype Cycle blockchain from 2016, blockchain is very high on the peak of inflated expectations, and nobody really knows a lot about it, or at least there is only few experts that knows a lot about blockchain. So we found that would be an interesting topic to dig into, we also soon found out that the blockchain technology overall, a lot of ideas are existing about what it can be used for, and there is actually not that many things that we haven't heard a use case for blockchain, but it's not that easy. There is, I think maybe there is too much enthusiasm about what it can actually be used for. Our approach has been in collaboration with Kim and Lasse in the Stibo Accelerator to look at with the eyes on identity management and this GDPR, and to make it a little more relevant. And as we at Aarhus University mostly look from a societal science research perspective, we normally want to figure out cause and effects and study why things are the way they are. Omar and I chose this time to come up with something new instead, and we have followed a design science research approach. So by doing that, we have been investigating this topic, trying to understand what it is, and then seeing how we can apply this to solve an actual business problem, that is the GDPR. To do that, we of course needed some experts to talk to, and the Stibo Accelerator offered us the opportunity to go to London, where we attended a blockchain expo, where we got an opportunity to talk to a lot of all these enthusiastic people with all their ideas about what blockchain could be used for. So we got a lot of contacts, and some of them agreed that we could contact them afterwards in order to talk about our project, and they could provide some insights and help us with the overall thesis work. And then of course we wanted to learn and have fun, and we would very much like to thank the Stibo Accelerator for providing, and Stibo for providing these lovely surroundings for that. Yes, and the General Data Protection Regulation is a regulation from the EU that takes effect on the 25th of May 2018. And we have written down here a few of the points from the GDPR, and these are the things that we think that is solvable by systems, by making systems that can help organizations deal with these challenges. And this regulation is going to have an impact on all organizations, also Stibo. And the idea is that it wants to provide all individuals with an increased control of their personal data. So for instance, when this is taken into effect, people would have the right to be forgotten. That is, they have the right to go to an organization and say, now you need to delete all the personal information that you have gathered on me. So the organization will have to do that, and that can be a challenge, especially if you have a lot of different systems containing these informations. Another point is the right of data portability, which means that if you go to a retailer, for instance, and ask them to provide the information they have stored about you, they'll have to give it to you so that you can bring it with you electronically and then give it to maybe a competitor. So it would be easier for consumers to move around in the competitive landscape. These are just, as I mentioned, a few of the points, and there is a lot more to it than that. But this is what has been relevant for our assignment. So what is blockchain technology? We have heard a lot of different explanations of how to understand it in an easy way, and I think the analogy I like the most is if you imagine a book with infinite number of pages, and that each page number is generated as a product of the content on each page. So one can imagine if you have a page with a story or a contract, for instance, and then the page number is generated based on that content. If you then later go and change the content, then the page number would also change, meaning that the page would not fit in the correct place in the book. So that makes it impossible to change a record in the blockchain, and that is one of the benefits of this.
So the general definition of a blockchain is it is a decentralized database that stores a registry of transactions in a decentralized peer-to-peer network. And these transactions are all cryptographically linked. If you consider, let's say, the first block here, it's named block 51, and they all have unique fingerprints. These are also called hashes. For example, here, this block here has this hash, and then it can be referred back to the last block, which could be block 50. And in each block, there's several transactions, which also has unique hashes. So you can always have transparency of your data. Next. Yeah. So why is it that we need blockchain? If you consider right now, we have transactions occurring constantly. You have payments. You have to track shipments. You make multiple transactions right now. And for example, if you take an example of me and Jacob, if I make a transaction, he has his own book with his information, and I have my own book. If we refer to this analogy of the book. So there's multiple truths between our information. And he can, of course, change his information if he wants to, and I would not know about it. And this can cause human errors, or it can also lead to fraud. According to EU alone, every year there's 256 billion in cost because people lose their identities, and there's a lot of identity thefts and frauds through it. Next. So, and as we refer back to this little comic where everyone thinks that I want a blockchain, let's have a purple blockchain with a huge RAM. But this is not the case. If you consider this picture, blockchains can be used where there's transactions between several parties. Compared to the old ways, right now what we have a centralized organization that settles different payments, for example a bank. And here is where the banks are afraid of the blockchain, because now you do not need the banks. You have several computers that verifies the transactions you do. So, in summary, to use the blockchain, you need to be in an environment where there are several parties that makes transactions, and these several parties needs a common view of information. These several parties also wants to know if there's any changes that has been done to this contract, or that you have, or this information that you have set in the database. And there's always a requirement between these different parties that it is also valid. You need to trust that this information is valid. Yeah. So if you look at this blockchain, how it's actually worked, how does this transaction becomes valid? If you look at this side, let's say me and Jacob are doing, I'm sending him some Bitcoins. And for this to work, I have to send it in this application, you could say. And this transaction is then sent to the blockchain. Here you have multiple computers. These computers try to solve a mathematical puzzle that tries to say, does this information I have sent to Jacob, does this money that I have, I'm sending to Jacob, do they exist? Or is the information I'm sending, is it from the right person I'm sending? Is it from the right account? If it does, then this information is verified and it gets sent to the blockchain. If it does not, it is rejected, meaning there's something wrong with the transaction. There's some information that does not have something. There's some errors in the information. So now we'll look at the blockchain architecture. So right now we do not need to invest a lot in hardware to actually access the blockchain. The blockchain itself is out there right now. You just need access to the internet. However, you do need to download an app that you can have on your phone. You can actually go to the App Store and download something called a Bitcoin wallet. This way, you get access through an API that connects you to the blockchain network. Here you can then be able to send transactions, and you can participate in the validation process also. So since 2008, where the original blockchain, Bitcoin blockchain, was created, there are now several blockchains. The Bitcoin blockchain itself is called the public blockchain. Here, everyone has access to it, everyone can send transactions, everyone can read information. And then you have private blockchains, which are against Satoshi Nakamoto's original plan. Here you have a fully control over your permissions in the blockchain. It is one organization that controls it. You can actually compare it to a traditional database, just with the blockchain features. And then you have a consortium of blockchains, which is a blockchain where you have pre-selected members. Let's say you have 10 banks, and each of these banks controls one node. And one node can be a computer, a smartphone, and to validate transactions within this consortium, you need 7 or 6 of these banks to approve of it before it becomes valid. And there's of course pros and cons between the public blockchains and the private blockchains. The biggest cons of the public blockchains is that it's very slow. This is because of the validation process, proof of work, where several computers tries to solve this mathematical puzzle, and according to some articles, it is the equivalent of the energy consumption of Ireland. So it becomes very expensive. And private blockchains are, however, much more faster within the transaction validation, and it's cheaper. So in our case, blockchain solution, we focused on smart contracts, which is an update from the original blockchains. You can call it blockchain 2.0, where you can codify a contract, you can put business logic in it, so it can self-execute. You can use your digital signatures to trigger events within these smart contracts. Let's take an example here. Jacob and Mette, Omar and Camille, wants to exchange properties. He wants to buy a house from me, so we make a contract. However, Jacob thinks that the price is too high, so he makes a change. In this little network, everybody gets a trigger message that says something has changed in the blockchain. So everybody gets a notification, and for this blockchain, for this smart contract to execute, everybody needs to approve of it. You can do it through digital signatures. And then this means after this process has happened, that means that the property now belongs to Jacob without a third party.
Yeah. And in our case, with the smart contract and the blockchain, we soon found out that storing personally identifiable information on the blockchain would not be a feasible way to go. That is, for one, the right to be forgotten, which is part of the GDPR. And as blockchain is a record storing, it records all the transaction and they cannot be taken away later, then that is against, of course, the right to be forgotten. So therefore we needed to find a different approach. And that became the consent contract. So instead of storing the information on the blockchain, we thought that we could maybe allow, if we said, let's take the example here with me, Jacob here, and the bank, they now need to have a consent that they can use my information in our customer relationship. So instead of me providing my information on the blockchain, I agree that they can use certain attributes like my first name, my middle name, and my last name, address, passport number, etc. But these information are not stored on the blockchain. Only the fact that I have agreed with the bank that they can use these informations are stored on the blockchain. So by doing that, we do not have any issues with the GDPR, and we have a certainty that both me and the bank knows what information they are allowed to obtain and store. So that is solving the consent part of the GDPR. So yeah, the information stored in this contract is either yes or no with regard to each of these data attributes. So that is where we ended with the project. So yeah, as you already probably can hear, there is a lot of different ideas about what we can use the blockchain for, and there is no. It's pretty certain that we're going to see some changes in the way we use databases and make databases today and in the future, but it is a very immature technology still, so there's a lot of things to sort out. But yeah, it's exciting to see what other use cases comes along. And yeah, thank you very much for attending, and again, thanks to Steve.